In this video, we're going to talk about a type of number called irrational numbers. The term irrational number is one to describe a specific type of number. An irrational number has two very specific characteristics. First one is that it has a non-terminating decimal. What that means is that the decimal just goes on forever. The other characteristic is that it has a non-recurring decimal, which means there's no repeating pattern in the decimal. So an example of a number like that would be something like 2.010010001 and so on, repeating that expanding pattern. So the numbers actually don't repeat. There's one more zero every time, and it never ends, which would make this an irrational number. So that's all fine and good, but why is this important? Why are we even talking about this? In other words, why do we care? So when we're dealing with these numbers, it's important to know that, first, irrational numbers can't be rounded and stay accurate. So if we're talking about an irrational number, technically saying 2.01 would be inaccurate and incorrect. The other thing we want to remember is that irrational numbers cannot be turned into fractions. So we can't round them, we can't put them into fractions. We need to communicate them in some way. And we're definitely not writing out numbers forever. So the most important example of an irrational number explains this quite well. So you might have seen this symbol before. This is known as pi. It's a very specific number. We can start pi by saying 3.14, but then of course it's non-terminating, so it goes on forever, and it's non-recurring, so there's tons of different numbers here that don't repeat in a pattern. So 3.14 is usually good enough to say that we're talking about pi, but if you're ever doing any calculations outside of school, so calculations that really impact a real-life situation, you need to be as accurate as possible, so you actually need to use all the numbers of pi. Don't worry, mathematicians have figured out a hack for this. So if we look closely at the scientific calculator, we can actually see that there is a pi button. So when you use this button, instead of saying 3.14, you're actually using all the digits of pi in a really accurate way. So that's one way that we've got around this whole idea of irrational numbers. We also run into irrational numbers when we start talking about square roots. It's important to know that if we do square root a number 2, we're going to get an irrational number. So you try that on your calculator. You find your square root button, 2, you're going to get something like 1.41 4213562, and then my calculator stops. That's a really hard number to deal with. If we're not going to round it, if we need to be super accurate, but we don't want to write a huge number like this, what we're going to do is actually just put this where we need it to be in our communication. So I'm going to give you a list of some numbers. If they are rational, or the opposite of irrational, you're going to put them on your number line in a rounded form. But if they are irrational, you're going to keep them in this square root form. Here's your list. So I want you to find the value of these three numbers, and then you're going to put them on your number line slide. Once you've updated your number line, you're ready to move on.